Hi, my name is Vladimir. Welcome to a new video. In this video we will learn how to make the Wronskian using MatLab. First, we must know the definition so we can understand what the Wronskian is. The Wronskian is a determinant that serves to know if a set of functions are linearly dependent or linearly independent. When we have two functions y1 and y2, the Wronskian is written as follows: w of y1 and y2, and the determinant is defined as follows. In the first row, the functions are placed, and in the second, its derivatives. When we have three functions y1, y2, and y3, the Wronskian is written as follows: w of y1, y2, and y3, and the determinant is defined as follows. In the first row, the functions are placed, in the second, their derivatives, and in the third row, their second derivatives are placed. And when there are n functions, the determinant is as follows. And in the last row will always be the derivative n-1. So if the Wronskian is different to 0, the functions are linearly independent. And if the Wronskian is equal to 0, the functions are linearly dependent. Now that we know what the Wronskian is and what it is for, we see an example in MatLab. Since we have the software open, let's click on New, and we select Script. And in this part is where we will write our code to solve the Wronskian. To get started, we must mention a variable, because it is with respect to this to which it is derived. For this, we put sims, and we put the letter, in this case is x, our variable. Now we are going to insert the functions. For this, we use the input command, and we put it in the following way: in parentheses and apostrophe. We will call our functions a and b, and we put it in the following way: a equal input parentheses enter the first function, and we make the same step to the function v. Now we are going to put the derivative of these functions. For this, we call the derivative of a like double a equal. We put the diff command. This command is to have the derivative of a function, and we put diff parentheses a, because of we want to have the derivative of this function. And for the second function, we call the derivative with w and we make the same step. The next step is to put the determinant. For this we call it as Wronskian, and we put it as the following way. First we put the function a and the function b, and in the second row we are going to put the derivative of the functions, in this case double a and double b. And now to have the determinant of this Wronskian, we are going to put that command, and we call this step with the letter W, and we have this W is equal to that Wronskian. And now we are going to put two conditions, because we know that if the determinant is equal to 0, the functions are linearly independent. But if the determinant is equal to 0, the functions are linearly dependent. To put these conditions, first we have the command if, because we have a condition, and we put if w is different to 0, this parenthesis and we write this case if the Wronskian it's different to 0, the functions are linearly independent. We write it in this part. And the second condition is that the Wronskian is equal to 0. We want the software puts on the desk a message that says the functions are linearly dependent. For this we put else w equal to 0, this parentheses the functions are linearly dependent. And that's all in our code. Only we have to put n. And now we have to save the file. For this, let's click on save and save as, and here we put the name what you want. For example, I'll put Wronskian 1. Then we have to run the program. For this, let's click on this part and run. And we have this say enter the first function. and here we write a function that you want, for example x. Enter the second function. Here we put x to the second power, and here we can see that the program makes the determinant, in this case the Wronskian, it's different to 0. For this case, the functions are linearly independent. In the determinant, we can say that in the first row we have the functions, and in the second row we have their derivatives. This case is only for 2 functions, and now we are gonna see how to do the Wronskian for 3 functions. To add a third function, we go back to the code, and in this part we are going to write the function c. It's equal to input parentheses, enter the third function. And also we must calculate their derivative. For this, we put C equal if command parentheses c, because of we put the function called c. And in this case, we must calculate their second derivative. For this, we are going to put this way: triple A is equal to div command double A, because of we want to have their second derivative, and we make the same with the another 2 functions. Triple B equal div bv, and triple C equal to div double C. And also we want to add this function in the determinant. For this, we put c double C, and we have to add a third row where the second derivatives will be. We have triple A, triple B, and triple C, and that's all. We must to save the change, and we have to run the program. It says enter the first function, and we are going to put the next functions. The first is exponent, the x. The second function is cos of x, and the third function is sin to x. And we can see that the program makes the determinant. In this case, in the first row, we have the functions that we put in the program. In the second row, we have their derivatives. In the third row, we have their second derivatives. The Wronskian is this that we have here. For that, the functions are linearly independent, because of the Wronskian is not 0. Now let's see the next example. The first function we put x. The second function we put x to the power of 2. And in the third function we put 4x minus 3x to the power of 2. And let's see. In this case, we have the functions in the first row, their derivatives in the second row, and their second derivatives in the third row. For this case, the Wronskian is equal to 0. For that, the functions are linearly dependent. And that's how the Wronskian is done using MatLab. I hope you liked the video. Until the next.